All right, so this is the key to the worksheet on rational expressions, number 10. And on this worksheet, you had three rational equations, and you had to solve these rational equations. Now, to solve these rational equations, we're going to, in all cases, multiply both sides of each rational equation by the LCD, the least common denominator, to clear these denominators. So in the process, at some point, you want all of these denominators to have a factor of 1 at some point. Okay, all of those denominators. All right, so let's look at number 1. And so number 1, we have r minus 6 divided by 4r plus 3 divided by 5r equals 3/5. All right, so I have this rational equation. All right, now this rational equation is made up of rational expressions. And the first thing you have to do is to make sure that your denominators are factored. And because you've got to find the least common denominator. Well, if you look at these rational expressions, all of the denominators are monomial factors. And so therefore, in terms of factoring, like you would normally do when you think of a binomial or a trinomial and so forth, or any polynomial with more than one term, in this case, since these are just monomial factors, you're just going to find the LCD, go straight to finding the LCD. So the LCD, remember your LCD must include every factor you see. So I see a factor of 4, okay? So let's talk about the coefficients. I have a factor of 4, I have a factor of 5, and I have a factor of 5. So it's the smallest number, the least common denominator that 4, 5, and 5 will go into evenly. All right, so the answer will be 20, right? Because 4 goes into 20 and 5 goes into 20 evenly. Now, remember, always use the least. If you use something like 40 or 60 or 80, 4 and 5 will go into all of those, but it's not the least. Those are common denominators. Those are common factors. Okay, so that will be a little bit more of an issue if you don't use the least. Okay, then in terms of the variable, I have a factor of r. I have a factor of r. I don't have any factor of r's here, so I just need one factor of r. So 20r is your least common denominator. Okay, now you have to find the restrictions. Okay, so you have to determine, and that's going to be important in some cases, you have to determine for which values of the variable is this rational equation undefined. And basically all you do is look at your denominators. Look at your denominators and then determine what makes this denominator 0. Because remember, a rational expression is undefined when the denominator is 0. So if I think about 4r, and that's easy to think about because those are monomial factors. When I think about 4r, 4 times what number is 0? Well, 0, right? Or 0, because 4 times 0 is 0. So in terms of the restrictions, then what that would imply is that r in this case cannot equal 0. Because if r was 0, then 4 times 0 is 0, and then again, if r is 0, 0 minus 6 is negative 6. So negative 6 divided by 0 is undefined. Same thing here, 3 divided by 0 is undefined. Now this is never 0 because it doesn't have a variable expression in the denominator. But that's the only restriction. R cannot be 0. And so you do the same thing with it. Remember, you got to check all factors. You got to deal with all factors. So if we look at the next one, 5r equals 0, same thing. 5 times what number is 0? Well, 5 times 0 is 0. All right. So there's only one restriction here. So now what you're going to do is once you find your least common denominator restriction, now we're going to multiply both sides by the LCD. Now, just like we've done in the past, you see how there are two, you can think of these as two terms here. you got to put that in parentheses because all of these terms on the left, and there's only one on the right, has to be multiplied by 20r. Okay, but mathematically the process is this. You remember what you do to one side of the equation, you have to do to the other side of the equation, right? So you got to multiply both sides of the equation by the least common denominator. All right, and then this part's going to go here. So we have r minus 6 divided by 4r plus 3 divided by 5r. And on this side, I have 3/5 times 20r. Okay? All right, now, remember, you have to distribute first, because if you reduce first, then that automatically is going to give you an error. Mathematically, it's not correct. Because remember, every term at some point in this step right here that we're about to write, every term has to be multiplied by 20r. So if you reduce first, if you reduce this and then distribute, what's that? That would be a 5 and distribute a 5. That's incorrect because then you're saying that 3r is only multiplied by 5, and that's not true. 3 divided by 5r has to be multiplied by 20r. So distribute first, and you need to show this part. This is what I'll be looking for. And so you're going to get 20r times r minus 6 divided by 4r plus 20r times 3 divided by 5r equals 3/5 times 20r. Okay? Now remember, we mentioned earlier that when you multiply both sides by the least common denominator, and the reason we're multiplying both sides by the least common denominator is to get these factors in the denominator to be factors of 1. And so now you'll see that's going to happen. Because look, 4 divided by 4 is 1. 4 into 20 is 5. Okay, so 20 divided by 4, 20 divided by 4 is 5. It's 5 over 1, which is 5 divided by 1, which is 5, right? And then the r's divide out. So r divided by r is 1. R divided by r is 1. Okay, if I go to the next term, 5 into 5 is 1. 5 into 20 is 4. The r's divide out. Now again, make sure you put factors of 1s in their place. Just don't cross these things out. All right, because if you do, you're going to mess up here as well, because that should be a 5, not a 1. So it's important you put, when you cross these factors out, that you put what factor is left. And then over here, the 5 will divide into the 20. That will give you 4. And that's about all you can do in terms of reducing. Now let's go ahead and simplify. All right, now you need to be careful here. So you need to rewrite things correctly. So this is 5 times 1 is 5. And then 5 times r minus 6. So you need to write it like this, 5 times r minus 6. So that's what this represents. Okay? Plus, and then 4 times 1 is 4. 4 times 3 is 12. Equal. And then here I have 3 times 4 is 12, and 12 times r is 12r. All right, so that's where I'm at. So notice I went from this rational equation, and it looks like I have a linear equation, right? All right, so let's solve this linear equation. To solve this linear equation, we're going to distribute the 5. And so I get 5r minus 30. 5 times negative 6 is negative 30. Plus 12 equal 12r. All right. Now combine like terms on the left side. Negative 30 and 12 is a negative 18. So I get 5r minus 18 equal 12r. And I'm going to go ahead, since there's only since the variable's on both sides, and there's only one constant, and that's on the left, I'm just going ahead and bring the variables to the right. So I'm going to subtract 5r from both sides. Again, what you do to one side, you do to the other. And so when you combine like terms, I get 0 here, 0 and a negative 18 is a negative 18, equal, and then that's going to be 7r. And then you divide by 7, and you found your solution. Oops, sorry, 7 divided by 7. And so 7 divided by 7 is 1. So you get r to be negative 18 sevenths. And then if you can reduce the negative 18 sevenths, you do that. Now, you notice I boxed it off, but what we need to also now check is that since this was a rational equation, I've got to make sure that this solution is not a restriction. Okay, And it's not, because notice negative 18/7 is not 0. All right, so if I did all this work correct, if all of this work is done correctly, then this, if I check, will be a solution to the original equation. Okay? All right, so that's number 1. Let's look at number 2. So number 2, we have, let's see, we have this in number 2. We have 4 divided by x minus 2 plus 11 divided by x plus 2 equals a negative 44 divided by x squared minus 4. All right, so two things you gotta deal with is first of all, make sure you understand what you have here. So I have an equation. I have a rational equation, and I got to solve this rational equation. The approach that we are going to take to solve this rational equation is we're going to multiply both sides of this rational equation by the least common denominator. Now notice that in this particular case, those denominators are polynomials with more than one term. So I need to factor those. Well, if you look at x minus 2 and x plus 2, I cannot factor those any further. The GCF in both cases is 1, but here, that's the difference of 2 squares. So if I factor the difference of 2 squares, I get x minus 2 times x plus 2. Okay? All right, now, for the least common denominator, remember, your least common denominator must include every factor you see. So I see a factor of x minus 2, I must use it. I see a factor of x plus 2, there's only 1 here, I'm going to write it here. I go to the next, I see a factor of x minus 2, there's only 1, I already have that one factor. I have an x plus 2, there's only one factor of x plus 2 here, and I already see one of them. So that's your least common denominator. Okay? Now, again, we got to find the restriction, though. All right, so that's going to be important. All right, so your restrictions, and again, you can have more than one, and you may not have any. Okay, but you can have more than one. So all you do is basically look at your denominators, and we're going to look at the ones that are in factored form when we get to this point. But over the first one, look at the factors in that first denominator, and if you notice I have x minus 2, and I need to see where is this equal to 0, so you set it equal to 0. And you solve this equation. Well, this is a linear equation, so if I add 2 to both sides, I get x, and then the combined like terms, negative 2 and positive 2 is 0, so I get x to be 2. So that's one of my restrictions, because 2 makes this denominator 0. And remember, you cannot divide by 0, so that's undefined. 2 minus 2 is 0. Same thing here. If I substitute 2 here, notice 2 minus 2 is 0, and then 0, and then 2 plus 2 is 4, so 0 times 4 is still 0, right? So that's undefined. This expression here would be undefined. So that's one of your restrictions. So one of my restrictions is that x cannot be equal to 2. If I do the next factor that I see, the next distinct factor from here, I get x plus 2 equals 0. And so in this case, x equals negative 2, and I solve for x. So that's another restriction. Remember, you have to look at every factor in the process, even from on the left and on the right. So x minus 2 is your next factor. I've already dealt with it. That's it. X plus 2 is the other factor. I've already dealt with it. So there's only 2 restrictions here. Okay? Now, once you do both of those, then the next step is to multiply both sides by the least common denominator. And notice that on this side you have 2 rational expressions. So I'm going to put that in parentheses. And let me go ahead and put that right here. So it'll be 4 divided by x minus 2 plus 11 divided by x plus 2. And remember, you're going to multiply that by the least common denominator, which is this. And so we have x minus 2, well, which is this right here, times x plus 2. Times, and then when I rewrite this part here, always rewrite the part, when you get to this step here, make sure your denominator is the one that's written in factored form. Okay, so don't leave it as x squared minus 4. leave it in factored form, and the reason is so that way you can see, let me go ahead and write it, so that way you can see those factors that you're actually going to divide out. Okay, so you can see those factors. All right, so now again, just like in all our discussions in the past, you need to distribute first. Okay, and so when I distribute, I'm going to get the LCD. Remember, that's the LCD. So you would say the LCD times the first rational expression. So x minus 2 times x plus 2 times 4 divided by x minus 2 plus the LCD times the second rational expression, x minus 2, x plus 2 times 11 divided by x plus 2 equals, and then again the LCD times the rational expression that's on the right side. Now notice I didn't put that in parentheses, there's just one fraction here. So you get negative 44 divided by x minus 2 times x plus 2 times the LCD. All right, now at that point, that's where you're going to then reduce. Now remember, the whole point of multiplying by the least common denominator, the whole point of multiplying both sides by the least common denominator was to get these denominators to be factors of 1. So I need to see that part. I need to see that you understand that. And so that understanding usually is shown when you do this. X minus 2 divided by x minus 2 is 1. See, those divide out. So you put factors of 1 in their place. So let's go to the next term. So the x plus 2's divide out. The factors of x plus 2 divide. It kind of makes sense because x plus 2 divided by x plus 2 is 1. So you see 1 divided by 1 is 1. And then over here, these factors divide out as well, right? Okay. And so now be careful when you rewrite it though. So actually don't do too much. Don't skip any steps to where you're going to make an error. So write it out. So 1 times x plus 2 times 4 is this at this point, 4 times x plus 2. Okay, plus, same thing here, x minus 2 times 1 times 11 is 11 times x minus 2. Write it out. Equal, this is a negative 44 times 1 is a negative 44. So that's where I'm at. Now notice I went from a rational equation to a linear equation. And so let's go ahead and distribute. And so I get 4 times x is 4x, 4 times 2 is 8, 11 times x is 11x, and then 11 times a negative 2 is a negative 22, equal a negative 44. Okay, so then the next step is to combine like terms on the left side. 4x and 11x is 15x. 8 and a negative 22 is a negative 14, equal negative 44. All right, and then adding both sides to 14. Remember, trying to get the variable by itself. And so then combine like terms. This is going to be 0, so I get 15x on this side equals, and then a negative 44 and 14 is a negative 30. And then finally, to get the variable x by itself, I'm going to divide both sides by 15. 15 divided by 15 is 1. 1 times x is x, equal. And then negative 30 divided by 15 is a negative 2. Okay? All right, now remember, you are dealing with a rational equation. So this is a solution to this linear equation that I have here. But is this a solution to the rational equation? And the answer is no, because x equal negative 2 is a restriction. So that means if you are saying x equal negative 2 is a solution, and you check your solution, you're going to notice that in this particular rational expression here, negative 2 plus 2 is 0. And 11 divided by 0 is undefined. Same thing here. Negative 2 plus 2 is 0. And then 0 times, and actually this would be negative 2 and a negative 2 is a negative 4. But particularly this, if you go back and you substitute here, negative 2 squared, negative 2 times itself is 4. 4 minus 4 is 0. So negative 44 divided by 0 is undefined. So negative 2 is a solution to this linear equation. That's a true statement there. But you remember, you are not solving, this was not the original equation. You are solving this, which is the original equation. Okay? All right, now here's what you're going to say. Since this is a restriction, and that was the only proposed solution that you ended up with, then you're going to say the answer is no solution. So this equation has no solution, and that's the work that you use to do this. All right, so remember this right here is a restriction. So you got to check your restrictions. That's the reason why when you have a rational equation, you have to list it, because when you solve these equivalent going from here to here, when you solve these equations that you end up obtaining, when you solve those equations, what you end up with may not actually be a solution to the original. All right, so you just got to be careful when you have rational equations. That's why you need to check those restrictions, so that way in your mind you notice, hey, that's a restriction, so I cannot say that's a solution. All right, so that was number 2. So let's look at number 3. All right, so finally number 3. So this is number 3 in this worksheet. It's really not that difficult as long as you understand the idea of the process of solving a rational equation, and then knowing a few things from previous lessons will get you through this. All right, number 3, we have 4 divided by 3x minus 3 plus 2 equals 3x divided by 5x minus 5. Okay? All right, so again, I have this rational equation. And it's made up of this rational expression, and this rational expression. And so what I have to do is, first of all, I got to find the least common denominator. And to find the least common denominator, since these are, if you look at your denominators, this is a polynomial with more than one term. This is 2 divided by 1. And this is a polynomial with more than one term. So I need to factor these polynomials. First of all, before I find the least common denominator. So this is going to be 3 times x minus 1. And this will be 5 times x minus 1. And so therefore your least common denominator, remember, must include every factor that you see. So I see a 3. I also see a 5, right? So the least common denominator of 3 and 5 will be 15. Don't say 30 or don't say 45 or anything like that. That is a common denominator, but it's not the least. Make sure you use the least to make things easier on yourself. The next factor I see is x minus 1. I have to put in my denominator. There's one factor here, because x minus 1 to the first factor, so there's only one here. There isn't any here, and there's only one here, so that's all I needed was 1. So that's your least. All right, so then I go to the next denominator, which is 1. But 1 is a factor of every expression. Then the next factor is 5. I've already taken care of that because 5 goes into 15. And then x minus 1 goes into x minus 1. All right, so that's your least. Okay, now I'm going to rewrite the original problem using the factored forms. It's important you use the factored form and not the original, so you don't end up doing something incorrectly. So we have 4 divided by 3 times x minus 1 plus 2 equals, and then 3x divided by 5 times x minus 1. All right, now one thing I forgot to do is find the restriction. So let's go ahead and quickly find the restriction. All right, so the restriction, remember you have to look at all of your denominators, and let's just look at the factors for each of those. So this factors a 3. And then notice that that's never going to be 0. It's always going to be 3 right here. This factors x minus 1. So let's think about when x minus 1 is equal to 0. So x minus 1 is equal to 0 and x is 1, correct? Because notice if I let x equal 1 and I substitute in the original. 3 times 1 is 3. 3 minus 3 is 0. And so I would have 4 divided by 0, which is undefined. And even on this side, when I substitute 1, notice, see this x minus 1 is a factor? I already have it. 5 times 1 is 5. 5 minus 5 is 0. And then 3 times x, remember x is 1, so 3 times x is 3. 3 divided by 0 is undefined. So, and then notice that that's going to be the only restriction here, would be that x cannot equal 1. So that's the only restriction. Okay, so then once you find both of those, then let's go ahead and clear the denominator. So remember, the whole point of multiplying both sides by the least common denominator is to get these factors to be 1s. This is already a 1 here, 2 divided by 1, right? Okay, so now let's go ahead and put those in parentheses since that's more than one fraction. And my least common denominator is 15 times x minus 1. So what I do to one side, I do to the other. Like 15 times x minus 1. Okay? And so now the next thing I need to do is distribute here. And so I get the LCD. Think of this as the LCD, which it is. But when you say it, say the LCD, which is 15 times x minus 1 times that first rational expression, 4 divided by 3 times x minus 1, plus the LCD times the second fraction. And I'm going to go ahead and write it as 2 times 15 times x minus 1 equal, and I'm just going to rewrite this over, 3x divided by 5 times x minus 1 times the LCD. Okay? All right. Now remember, notice that when you multiply both sides by the LCD, every term has to be multiplied by the LCD. So notice that this times the LCD is this. This times the LCD is this. Notice 2 times the LCD. And then this times the LCD. Okay? All right, now let's at this point, this is the way you would reduce. So 3 into 3 is 1, 3 to 15 is 5. So remember at some point, all these factors in the denominator needs to be written as 1s. X minus 1, those divide out. Over here, the next one, the denominator is already a factor 1, right? Over here, though, 5 into 5 is 1, 5 into 15 is 3. These divide out, you get factors of 1s in their place. And so notice you have, in your denominator, you do have a factor 1. All right, now, let's go ahead and rewrite this in a better way. 5 times 1 is 5. 5 times 4 is 20. Now on this one, let's be careful. Let's take our time with this one. So notice you are multiplying 3 factors together. 3. 2 times 15 times x minus 1. And so remember, when you are multiplying numbers, let's say numbers, you multiply from left to right. So when you multiply, the same thing with factors, you multiply from left to right. So 2 times 15 is 30. So let's write like this now. So 30 times x minus 1, just like that. Equal. And then you have 3x times 3 times 1. First of all, let's look at this. Remember, multiplication is commutative. The order in which you multiply does not matter. 3 times 3 is 1. So 3x times 3 is 9x. Y'all agree? All right. So now notice I went from a rational equation to a linear equation. So let's solve this linear equation now. All right, and so remember, you're solving this linear equation. So that solution you're going to end up with will definitely be a solution to this, but you need to check and see if it's going to be a solution to this by looking at the restriction. Okay, so let's distribute. Remember, mistake people make is they'll say 20 plus 30 is 50. You know you cannot do that. Because according to the order of operations, I have to multiply first before I add. So let's distribute. So we're going to multiply every term in the parentheses by 30 first. So 20 plus 30 times x is 30x. 30 times a negative 1 is a negative 30, equal 9x. Then combine like terms. 20 and a negative 30 is a negative 10, so I get 30x minus 10 equal 9x. And then again, let's just go ahead and subtract 30x from both sides. And so when I do that, I'm going to get, that's 0, and I combine my terms, 0 and negative 10 is a negative 10, equal 9x and a negative 30x is a negative 21x. And then dividing both sides by negative 21, remember, a negative divided by a negative is a positive, so that's going to be a positive 1. 1 times x is x. And then again, negative divided by negative is a positive. And then that's supposed to be 21, right? Okay, so 21. And so a negative divided by negative is a positive, so I get 10 divided by 21, and I can't reduce any further, so there's your solution. And I know that's going to be a solution because 10 divided by 21 is not this restriction. And so if I did all this correctly, which I think I did, and I'm sure I did, if I did all this work correctly, then this 10 divided by 21 is going to be a solution to this original equation. Okay? All right, so that was the key to worksheet number 10 on the chapter dealing with rational expressions and equations. All right, so that's the end of this key.